Alright, year 12. Eyes up. It's important, yeah.
Is it better than year 12? Did you score good?
Oh, wait. We need to create a function or a rule that works all the time. Happy with that? So if we have the function y equals give it x squared plus nx plus c. How do we go about, now let's keep the c on the same side, how did we go about completing the square? What was the thing we had to do? Half what number? Which is, so we get x squared plus nx plus what? No, we've got all the numbers we need. Half what? Half n. So how can we represent half n? Is it just n over 2? Now, we've just added n over 2 squared. How do we make that still work? How do we not break the laws of maths here? Do it to the other side, but I want to leave the y here. So how can I represent that?
Take it away.
Good. So, do you agree that, and I'm going to sub y, I'm going to get rid of this y, and I'm going to place the line above. X squared plus nx plus c. Do those two sides of the expression equal the same thing? If you would like to check, you can throw some numbers in. I'm happy for you to do that. It's a good question. Why did I add the n over 2? Because my next step... Not quite. My next step is to get x plus n over 2 squared. Okay, so all of this what happens to the nx? It's a good question. I'll do it over here. Alright. Yeah, there's just an arrow saying it's going down. Sorry, that's not a good spot for an arrow. That's a bracket. It's fair, it looked like it was continuing on. Okay, so when I expand this, which is what we're doing, we've got that's a square. That's x plus n over 2 squared. Happy with that? So if I do my little crab claw method, because I like to be back in primary school where I felt good about crab claws, x squared plus n over 2x, I should make that nx over 2, sorry, plus, so that's the first part done, nx over 2, happy with that? Plus n over 2 squared, that equals x squared plus, if I add those two up, I get nx. What's a half plus a half? So half of nx plus half of nx gives me nx plus n over 2 squared. Is that okay? If you don't need to write that down if you don't want. That's just purely showing you how this can become that.
So like if they just get rid of the NX, not get rid of
You wouldn't get rid of it. You just sub n in for a number.
no, like when we're like doing that with the brackets, it's just not right on it.
You won't write an x. You'll write x plus 7 over 2 or 6 over 2, whatever the number happens to be. Yeah, I'm using n so it works all the time. Happy with that? What else do I need to put in? Plus c minus n over 2 squared. And these two values here, I probably shouldn't have used c. Why am I saying I shouldn't have used c? It's a bad letter because when we add these two up, what are they going to give us? Our c value from y equals ax. I'm going to make this equal d. Make this equal d in your books. D. Why d? Because these two numbers together are going to be our c value.
So what's the bit on the second one?
This part, I'm just proving that y does equal that. So that's y. I'll get rid of that now. Why did I do it? It's because I wanted to get it. It won't work if there's too much talking. The room's loud. I wanted to get into this form. And the way you get into that form is to divide whatever your n value is. When we had 12 before, we knew it was 36. And then we got x plus 6 squared. So, not there, I've rubbed it off. We've got x plus 6. 6 is 12 over 2. So whatever number is in front of your x is the n value. You divide that by 2.
Are we dividing that by 6?
That is, no. Let's try and make this, I'll make it more obvious. That number will become our c value. That's why I didn't want to use c before. Cool? It will get easier once you have a practice, which is what we're going to do now. We're going to have a go. So, yeah, it will be numbers, yeah. It won't be, no. But the power of that is that it works for every situation, like for every number. So if I showed you a number, it wouldn't be as obvious. But here we go. We'll just go through a couple. Let's go question 10. Yep, 10A on 9.1. Just start with 10A, 9.1.